clusters there will be. When you will perform cluster analysis, you don't know those. No? So the canonical clusters are not known to you. Do you follow? So you will have to indicate how many clusters do you want to see. Clear? Okay, it's an open area for research in math to find out, given a set of variables and a set of individuals, how many clusters are there? It's an open question that no one has yet answered. Okay, please continue. So the purpose is to group individuals according to their similarities on certain measurable factors and variable. And its main use is to generate tentative theory. So when you are able to cluster, you should be able to generate tentative theories. It is also used in biological sciences for species identification. So for example, when you have a new organism, you want to classify this new organism into already known clusters. Please continue. Continue. Your data requirements for cluster analysis is that you should have observation for each characteristic that you want to define your observations on. For example, there are 4 characteristics I want to measure. So each individual that I will put in my data set should have income, nutritional status, level of sanitation at home, and availability of water. So each individual will have this characteristic. Okay? So for each individual, you will measure 4 different characteristics. Please continue. Now, we will cluster them according to distance. So you have to define the concept of a distance between 2 objects. The distance denoted by D of A and B between individuals A and B measures how far A is from B. So if DAB is 0, what is the meaning? Then A has the same characteristics as B. Is A equal to B? Not necessarily. No? Only on those characteristics that you have measured, they are the same. But they may not be necessarily the same person or individual. Please continue. So let's say I want to measure body odor. Okay? So, and body odor is this way. 0 if there is no body odor, and 5 is very odorous. Okay. So I'd like to cluster you according to this. Can we do that now? Can you smell each other? Okay. Suppose that you have an individual A whose X1 is 0, meaning A has no odor. And then there is an individual B with X1 equal to 5, very odorous. The distance between them is just subtract the coordinates 0 and 5 here, and then take the absolute value. Absolute value means it's always positive. Take the positive of that. So 5. So the distance between AB is 5. They are very far from each other with respect to body odor. Please continue. Now let's add some more. No? Apart from body odor, I will also measure the color of the skin. Where the color of the skin is 1 if light, and 5 if very dark. So A equals 0, 5 means no odor but very dark. This one is very odorous but very white. Okay? Generally true ra ba ni? Ang pution kay baho. Ang ituman kay humot. Okay. Kata ang baho. Saing. Kata ang mga negro humot na sila.
Pero Indian.
Arabo, puti pa na.
Mumbai.
Bombay. Light colored din na sila. Fair. Okay. So, from your geometry, distance between AB will be subtract odor to odor and color to color. No? So 0 minus 5, squared, so 0 minus 5 squared plus 5 minus 1 squared. Take the square root of that. And this is why you have to standardize. You see, what is in the bracket here are the coordinates. So if this is in percentage, this will be hundreds, right? And if this is in trillions, this will be very big. Then the distance will be dictated by something big. So that's why you have to standardize. Okay, so the distance between AB is 6.41. And then you cannot interpret that on its own. You have to compare it with some other thing. Like, you have two other individuals, C22. What is the meaning? Medyo siya na body odor o medyo siya na color. Kani? Medyo siya na body odor and itumon siya. Right? So the distance between CD would be like this. 2 minus 2 squared plus 2 minus 3 squared. Take the square root. That's 1. That means that A and B are farther away from each other than C and D. Mas dool si C and D. So if you were to cluster them, C and D would belong to one cluster, but A and B would belong to different clusters. Okay. Please continue. So these are the chart of the mathematics of this thing. You want to read it, you can, but I don't like to discuss that. Let's continue. Linkage rule, there are single linkage rule, nearest neighbor approach, and farthest neighbor approach. You can begin either by looking at the closest and then expanding, or you can begin from the farthest and then shrinking in clustering. Please continue. 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 Continue lang gihapon. Continue. Example na yun. So here is an example. You're looking at quality of education where you have data from 15 universities in the Philippines. And this is actual data. We look at performance and licensure exam, average tuition rate per unit, enrollment size, percentage of those with doctoral degrees in the faculty, and the rejection rate per 100. That is, out of every 100 who took the exam, how many do you reject? That's the rejection rate. Let's continue. And the data is like this. The first university has 87 as the average in the licensure exam. Tuition is 700 per unit. Enrollment is 6,000 with 60 PhDs in the faculty and rejects 80% of its applicants. So only accepts 20%. In contrast, this one rejects 5% and accepts 95%. I don't know in your university what your criterion is. 0% rejection? Manimahong tao, okay na. Okay, let's see what happens. So I will input all of this. Please continue. So the steps are go to stat, go to multivariate, cluster observations, click all those variables, and then show the dendrogram. Input the number of clusters because there is no canonical clustering here. There is no natural clustering. You have to specify that. And click OK. Please continue. Here is a dendrogram, and I ask for 3 clusters, so that's 1. Where's the 1? 1, 2, 3. Okay, please continue. So 5, 9, 1. These are the clusters. Please continue. Here, what do you notice right away? Pwede, 2 ways you can approach this problem. No? You can either compare the variables across the clusters, in which case you will say that those in cluster 1 are the best performing schools, those in cluster 3 are the worst performing schools, right? And those in cluster 1 are the more expensive schools, those in cluster 3 are the least expensive schools. And then those in cluster 1 have very high rejection rates. Those in cluster 3 have very low rejection rates. So they accept almost everyone. You can do that, no? Or you can focus on one cluster, like this. Cluster 1. How do you think first you have to choose what your dependent variable is. So let's say that exam. Then you look at this as independent variables. Tuition, enrollment, PhD. How do you think this relates with exam? Okay. How you think enrollment relates with exam, and so on. So pwedeng yung imong tanaw across clusters, or pwedeng mo concentrate ka sa cluster and then identify a dependent variable and do regressions, no? For each cluster. Regression, I mean by variate regression. Do not do a multiple regression. So sahon mo siya, pangitan. Exam versus tuition. And suppose that you find that the optimal relationship is like A plus B times tuition plus C times tuition squared. And that gives you an R squared of, let's say, 97%. And then you will also do a bivariate regression on A plus number of PhDs minus, let's say, minus C times PhD squared with an R squared of 98%. Okay? If you want to do a multiple regression, you will put exam equals tuition squared, PhD, and PhD squared. Wala naman sa. There you go. So, okay, now this will delimit my sphere of influence. Okay, using common sense, just move this. Pag-uban to kay ang iyong pukson, ikatumay yung birahon. Saksakanan. And that's what I don't like. Not using common sense. Yeah, using common sense. But now the problem here is, you're not able to see. But never mind, it's not dedicated for you anyway. Okay. So, you have these two bivariate regression. Bivariate means exam and one independent variable. If you want to do a multiple regression on exam, it's exam, not just tuition, but versus this model. Okay, tuition squared, and then PhD squared, and so on. Do you understand? So instead of just tuition and PhD and yung input, it's called naive approach. No? Naively, you put these two linear variables as predictors of exam. First, pick the best model for tuition and the best model for PhDs, and then put these two as predictors of exam. Do you follow? And that will maximize your R squared. Am I making sense? Tagalogin natin. Ito na. Una, go to the cluster. By go to the cluster, I mean select those variables, no? So select those individual observations that belong to this cluster. Okay, then you do a regression bivariate per variable. That is, wala na siya kasabot na ng bivariate. Ano naman si ma'am? Ano naman bivariate eh? Ako nang paliton?